Shri YV, Assistant Professor, Department of Electronics and Communication. In this session, I am going to explain how UART has been used for the serial communication. Before going on to the UART program, let me discuss the important registers which are used in the program. First one is FCR. FCR stands for FIFO Control Register, which has particular bits out of 38 which is used for particular operation. So bit 0, it is used for FIFO operation. Bit 1, receiver FIFO. If it is set to 0, no impact. If it is set to 1, it clears the receiver FIFO and also the pointer. Bit 2 is for transmitter FIFO. Bit 3, DMA mode. So this is for enabling or disabling a DMA. Bit 7 and 6 is for receiver trigger. This bit is used to select the number of bytes of the receiver data to be returned so as to enable the DMA. The other registers which we are going to use is LCR. LCR stands for Line Control Register. This is also a 32-bit register in which bit 1 and 2 is used for word length select. We are going to select the character length. If it is 00, 5 bit, 01, 6, 107, 11, 8 bit. Bit 2 is for stop bit selection. If it is set to 0, number of bit stopped is 1, otherwise it is 2 bits. Next is the parity enable. If the bit is 0, means we are disabling parity generation and checking. If the bit is 1, we are enabling it. Bit 54 is for parity selection. Bit 6, break control. Bit 8 is for divisor latch button. Another registers used is the LSR, that is line status register. This is a read-only register which provides the status information of UART transmission and receiver block. If bit 0 is set to 0, then UART receiver FIFO is empty. If it is 1, then UART receiver FIFO is not empty. Bit 1 is for overrun error. If that bit is 0, no overrun, or else buffer is overrun. Next is for parity error. Bit 3 is for framing error. Bit 4 is for breaking the interrupt. Bit 5, it is the transmitter holding register empty. We have the short form, that is THR. Bit 6 is transmitter empty. Bit 7, receiver error FIFO. If that bit is 0, means the RBR contains no UART transmitter receiver errors. So let us see the program now. This is the UART program. First one, we have to include the necessary header files. We are declaring the clock frequency equal to 12 MHz. We are using two different frequencies. One is FC clock, that is 12 MHz into 8 times frequency. FCCO, that is 3 times of FCCLK, and FPLK is FCCLK divided by 4th frequency. So these 3 frequencies are being used, and the baud rate what we have set is 9600 for serial communication. Then we shall start with the main program, int main. Here you have to see first the buzzer has been set. So that is the port of GPIO3 port 3 and particular bit has been set. Then we are calling the system initialization and UART initialization programs, and then we are sending the byte that is hello, some message, Rajiv Gandhi Institute or something. Let me change this to SJB Institute, and we are sending the D and A, that is the carriage return and the line field. Then we are clearing the buzzer sound. So we'll start with what are these functions. First is the UART initialization, where we are going to set pin number 4 of pin select 0 register equal to 1, so that we are enabling the access to divisor latch. And then pin number 6 has been set, that is port 0 third bit has been set. And then 83, it is because it's a 8-bit character length, and we are enabling the access to the divisor latch. So you can look into this LCR register, then we will understand why is it 83. Then using this clock frequency division, we are operating at 9600 baud rate. Then using this line LPC UART LCR equal to 0x03, we are making the character length equal to 8 bit. The next one, FCR equal to 0x06, it's a FIFO control register, that is it clears the transmitter FIFO, resets the FIFO ports. So now after resetting the FIFO ports, we are sending the byte. What is this UC data? That is the data what we are sending here, hello SJB Institute. So that data has been sent, and that data will be sent to the UART. So here we are making sure, why we are ending it with 20 years, we are making sure that UART receiver FIFO is not full. And what is this THR is the transmitter holding register. When it is 0, the register is empty, and when it is 1, it has a valid data to be transmitted. What is the valid data? UC data is to be transmitted. And then the getChar function, that is while of LPC UART to line set register. Here we are making sure that the UART receiver FIFO is not empty by ending it with 0001, and we are using the content like RBR. RBR is the register which contains the information that UART receiver errors are there or not. If this value is 0 means no error. If RBR is 1 means there is at least one error. So after getting a character, we are discussing what is this UART send string. So the parameter what is being passed is dot star s. When it is not equal to 0, you are sending the byte continuously. This is the logic of the program. Now we will start with the kill version. We'll create a new project. So in the same ESD folder, I am creating another one project. Say UART project file. Give save. Same device has been used. EMSISL code should be selected. In the device, startup should be selected. Click on OK. On the target, look for options. Use microlib has to be selected. In the output, create X file has to be selected. Give OK here. So click on new file. Paste the program, copy paste, or you have to type it. Save the program. Give a name with the extension C. Okay, you need to add that file to the source group. Add the file, close it, make sure the file has been added here, and then check for the errors. It will take little time, few seconds. Next, build, and the next option would be to rebuild the file. Once you are making sure that no errors are there, then the X file will be created and we have to download that X file onto the ARM controller kit. See here, creating X file. So no errors. So now we shall go with this Flash Magic software, wherein the devices were PC1768, port is COM3. We have to make sure about this port, and these are the settings. Erase block used by X file has to be selected. Browse the file, so UART, select it, start. So you have to make sure the kit has been connected. So now start downloading the file. You can see that green bar. So in UART, you will always see the output in the terminal, which is the port COM3 9600. Click on OK. You can see the message here, hello SJB Institute. This is how the UART transmission takes place. The Viva question for this experiment would be, you need to understand what is the UART, what are the modes of UART transporting the information, what are the registers being used in UART communication, what is the speed at which it works. So you need to understand what is the structure of the queue. Then you need to understand what are the registers, that is LCR, LSR, THR, RBR, what is the working of it, how can we use it and all. So these are all the Viva questions for this experiment. Hope you all understood the program. Thank you.